In this video, we start to get into some real code. First we'll take a look at what an IDE is and how it helps, displaying text on output console, and also what are variables, how we create them, assign them values, and then use those values. So let's start with the Visual Studio IDE. As our IDE, or Integrated Development Environment, Visual Studio packs in a lot of tools to help us work faster, as all good IDEs should. Firstly, Visual Studio is a text editor, but not a normal text editor. Other tools within Visual Studio track what we are typing and highlights words and symbols in certain ways to make code easier to read. It also adds suggestions when typing. This is useful for suggesting variable names, functions, namespaces and other things. It also allows shortcuts to be used. An example of this is typing in CTOR and then pressing the tab key to automatically create the constructor for a class. We'll be looking at classes later. This is just a sampling of the helpful functions Visual Studio provides. Once we have written our instructions in text, in this case it will be C++ syntax, it is still just text, no different than what you would write into a word editor. So how do we take this text and make it into something a computer can understand as instructions to execute? We need something that will look through our text file and convert it into machine instructions. This tool is called a compiler. A compiler is simply another program that we run and give it our file or files. It looks through the file and creates machine instructions based on what is in the text. In Visual Studio, this compiler is also included, so when we select the desktop development with C++ option when installing Visual Studio. Visual Studio also has some other cool features for navigating through your projects quickly, placing stop points in your code to allow you to interrogate variables and their values, and it also has integrated Git features for source control and a whole host of others. All these tools can be sourced separately. We are not required to use a complete and integrated environment, and before the introduction of IDEs, the norm was to have these tools as separate applications. As Microsoft has developed Visual Studio to be as seamless as possible, it helps to improve developers' workflows and develop code easier and quicker. The community version, although lacking some professional features, which we don't really need here, provides all of the features I've described above. And last time I checked, if you work in a team of 5 or less, then it's free to use. An industry standard development environment with professional tools and workflow and is free. Of course we chose to use this to get started with C++. Depending on the project, it's not always possible or even suitable to use Visual Studio. In the next C++ course, we will look at different editors we can use, different compilers, and targeting architectures other than Windows. Visual Studio will also help us push some of the more complex compiler, linking and project management tasks and concepts to later stages, so we can learn to code in C++ and progress quicker. All the skills we learn here will be used when we move on to coding for Linux, embedded systems, game programming and other areas. Moving on, I'm going to show the processes and describe the parts of a C++ application. Then we're going to take a look at the brief and use what we have just covered in order to fulfill the requirements of the brief. There is no need to follow along in this first part, although I would highly recommend following along when we come to the first example work task we have been assigned. This is the UI notification program for 2 cool systems. After going over the work task, I will also give you some additional work tasks to complete on your own. I recommend you try to work through these tasks, or at least attempt them. The example briefs and work tasks I provide are to help you reinforce the topics I cover in the videos. When it comes to programming, you only really learn when doing. You can watch every video on YouTube about programming in C++, but you won't actually learn how to program until you start actually making programs yourself. So let's go. Open up the Visual Studio IDE by clicking on the shortcut in the taskbar, which we created in part 1. We are presented with the startup screen. Once fully loaded, select the Create a New Project option. This takes us to the Project Creator screen, where we can choose what language we want, the environment we want to deploy to, and the type of project we want to create. So, in this order, select C++ as a language, Windows as a deployment environment, and Console as a project type. We are shown a number of options. The one we want is a console app. This will allow us to create a program that already has some code in it to display text to a console window. Now that we have the console app option selected, click on the next button. Now we come to the project configuration window. Here we can enter a name for our project, the location where we want to save our project to, and the name of our solution. The project and solution names are different. I won't go over that here, We need more information to understand that, and this is not the best point to do that. So simply make sure the project and solution names are the same for this part. When starting a new project in a new programming language, the convention is to create what is called a Hello World project. This is simply a means of setting up a template that does something we can see. This provides us with a template we can add to later. To honour that tradition, I'm going to call this first application Hello YouTube. Remember, you don't need to follow along here. This is just a demonstration setting up a project. As you can see, the solution name changes to match as you modify the project name. As for the location name, I want to keep with some kind of convention. So firstly, I'm going to create a folder on the C drive to store all of my projects. I'm going to call this folder Intro to Pro CPP. CPP can be used in file names where the plus symbols are reserved by the operating system and can't be used in a file name. Now click on Create. As a preference, I don't like to work with a white background, so I'm going to change it here. Go to Tools in the menu bar and then click on Options. In this window, make sure that Environment is selected in the left pane and then the sub-option General is selected. In the Colour Theme selection, we have a number of options. I prefer dark mode, but you can try out the available options and leave it on the one that you prefer. So select one of the options. In this instance, I select the dark mode option. Now click OK and you'll see the theme take effect. Yeah, much better. Now let's take a look at the template code we have here. Firstly, we see this text that starts with 2 forward slashes. These are code comments. This means that when we build these instructions into a program, this text is ignored. It is only here to give us developers some additional information. We don't need these here, so I'm going to remove these lines of text. We don't need the comments at the bottom, so I'm going to remove these also. This leaves us with some non-commented code. To go over this, I'm going to remove everything and add it back in piece by piece and describe what each part does. The first line, starting with a hash, then include, is a preprocessor instruction. Basically an instruction to the compiler to include other code into our file so we can use its features in the file we are working with. This is then followed by a library called iostream, which is encapsulated in triangular brackets. iostream is part of the C++ standard library for use in the C++ input-output stream. It has functions that we can use to send text to a console window or grab user input. The next part, int main open and close round brackets, defines a function called main. Each C++ application has one and only one main function. It's a bit too early to cover functions at this point, but what we can say here is that a function is a discrete block of code that can be reused. In the case of the main function, yes, it is a discrete block of code, but it is only used once. The main function is called and executed when the application is started. You can think of the main function as the entry point for your program. As such, there can only be one main function in your project. The line after the definition for the main function starts with an open curly bracket. We have a line of code that is indented to the right with one tab, the standard cout command, and then we have another line with a closing curly bracket. All the code between the opening and closing curly braces belongs to the function above. Again, in this instance, this code is in the main function. So when the application is ran, the code between these braces is executed in the order they are written. With only one line of code in this function, the standard cout call, only this instruction will execute and the program will end, as there are no other functions or commands written. The standard cout line of code is made of multiple parts. First, we have the std. This tells us we are using the standard namespace. We will cover more in namespaces later, but for now we can say namespaces are used to arrange functions into defined sections to avoid naming two functions or classes the same, as this would cause confusion and the compiler to complain. Cout is an output stream to the console. By placing the write-to operator after cout, we are saying that what follows is to be written to cout to the console. Cout is a stream. There are two operators used to read and write data to and from streams. These are the write-to operator and the read-from operator. In this instance, we are writing to the console, so we are using the write-to operator. The next part that is in quotes is text. The hello world part is normal text. The \n is what is called an escape character or escape sequence. The / tells the console that this is to be interpreted by the console as a command, and the n is a command for new line, which moves the cursor to a new line. By placing the \n in the string, we are telling the console to go to a new line. There are other escape characters for all sorts of things like moving the pointer, formatting the text, changing the colour, making the text bold, flashing and others. We will cover more on escape characters later in this course. The last part is a semicolon. Semicolons are used to end commands. This is helpful as it tells the compiler when the command has ended and then the next part is separate from the current command. By using this method, it allows the compiler to ignore white spaces, tabs, carriage returns, etc. As such, we can use white space without having any impact on the resulting program, allowing us to use spacings, tabs, carriage returns and others to lay out code in a more readable manner. We can remove all the white space here and place all commands on a single continuous line. There are a couple of conventions used in C-like languages, which C++ is to place includes, defines and other definitions on one line, code blocks on the next line after its class or function definition, and commands have a line of their own but tabbed to the right of the curly braces of the code block they are in. As we really don't care much about the amount of white space we include in our files, we can lay out our code as we please to make it as easy to read as possible. But keep in mind there are different standards used in different languages and workplaces, so when learning to use another language or code base, learn the conventions on whitespace used in that area. Use those conventions, become familiar with different conventions and try to become comfortable with different styles. This is important when we work in industry, as different software houses will have conventions and standards suitable for them, and if you work with a team, it's important to use a common style. This makes it easier to maintain a common code base. So let's build this program. Go to the build option in the menu and select build solution. Notice that there is a shortcut for build, which is F6. I'll be using this to build going forward, rather than going to the menu every time. I like shortcuts. After the build process completes, we should see the build details at the bottom in the build output pane. If I've made no mistakes in the code, it should say build 1 succeeded, 0 failed. Now we have a few ways to run our application. The first is to click on the run button that says local window debugger. Cool, it says hello world. Moves on to a new line, just like we described it should. There is also some other jazz displayed at the bottom, like application name, exit status and some other information for us. This is displayed because we ran it from the IDE. It also puts a stop point at the end to allow us to view the console before the window closes. We can press a key and the window will close. This is the main way we will run our programs, from the IDE, as we can also use other features for things like debugging and checking an output. Another way is to navigate to the build folder. In this instance, it is a debug folder, and just double click on the exe file that was built. Notice how it just closed after it was double clicked. This is because there is no stop point in the program, and once the instructions in the main function are finished, execution of the program exits. If we want to make the program stop before closing, we need to add something in the main function to do this. The last method we will look at is running from the command line. Open the project build folder, again this is the debug folder, in a console window and enter the name of the program to be executed. Because this is a console window, we are simply executing an application. We see the output, but the console window stays open. Keep these methods of running the program in mind, as we will use different methods to test and deploy our programs as we go. Don't worry if this all sounds a little complicated. We will cover all the whys as well as the hows in order for you to get a good understanding. Saying hello world is okay to get started, but it's not very usable. By changing the text between the double quotes, we can dictate what is displayed to the console. Adding multiple write to operators allows us to write more than one thing at a time to the console. Now we can start to construct some quite complicated sentences, but the rule of thumb here is to construct sentences that are easy to read, so spread them over multiple lines if you have to. Now that we can actually get something printed to screen, let's start looking at variables, storing data, and how to actually start manipulating data. Programming isn't really effective without being able to use data. In order to use data, we need to create containers that can store the data. These are called variables. C++ is a strongly typed language, meaning we need to tell the compiler what kind of data we want to store. There are a number of built-in data types in C++. These are called primitive data types, and are available for use without having to include any other libraries. The first one we are going to use is to store a whole number. These are called integers. To set this container up, we need to give it its type, in this instance an int, provide a name, and it's also good practice to give the variable a value when we create it. As an example, I want to store the number of years I've been developing software so I can display a custom message. So, first we define its type, which is an integer, or int, so we use the int keyword. We then give it a name. I'm going to use years developing. Assign it a value, and finally we close it off by adding a semicolon. So we have int years developing equals 9 semicolon. So now we have a container called years learning, and it contains an integer value of 9. So let's change our message to say, "Hi, I'm David. I have been developing software for 9 years. Instead of typing in the value 9, we are going to use the value from our variable. Here I am writing multiple values to the iostream cout function. Notice that the variable years developing is not in quotes. This takes the value stored in that variable container and writes it to the iostream. So let's build and run this and see what the output is. Excellent, the value stored in that container is now displayed to the console. Let's change this value to 20. Rebuilding and running again gives a different output. This is because we changed the value in the variable container before taking that value and writing it to the console. So now it is no longer 9, it is 20. So let's keep going. If I instantiate another variable, say years developing Jordan, initialise it with a value of 30. We now have two integers, one called years developing and another called years developing Jordan. We can store the sum of these two values by creating another int variable called sum years developing and initialise it to the sum of the previous two variables. So this would look like int sum years developing equals years developing plus years developing Jordan. And I'll display this result in the console using this line of code. Now, when we run this, we get two lines written to the console. One to display the years I have been developing, and the other for the sum. This is a simplified demonstration of how we can use numbers in formula. We'll be doing a lot more of this going forward. But what other variable types can we use? There are also what is called floating point numbers. These are used to store decimal values. Can you guess how you would instantiate a float? Like we did previously when defining the int variable, this time we use the float keyword, give it a name, and then end the line with a semicolon. In this instance, I am initialising it with a value of 2.5f. Notice this time I've placed a lowercase f. This tells the compiler that the value is a floating point number, mainly as a throwback from the C programming language, but it's still a good practice to get used to using. If a float value is too small, and we need to store a larger number, then we can use a double variable. This would look like this. The rule of thumb here is to use a double only where a float is not large enough. Most of the time, float would be sufficient for most uses, although this is not as much as a consideration as it used to be. Memory is much larger now, and it's not uncommon for even megabytes of memory to be available in embedded systems. Moving on to text. The primitive type for storing text is a char or character value, and would look like this. Notice the single quotes. Within single quotes you can only store a single character, and you can also only store a single character in a char variable. And if you want to store text in this primitive type, then you need a character array. An array is multiple instances of that type joined together like this. That looks awful. Here we use square brackets after the name to say this variable is an array. We'll go over arrays later on when we come to the algorithm section. Then we have individual characters with single quotes, separated by commas and encapsulated by curly brackets. There is a better way in C++, and that is to use a string variable. String is part of the standard string library, so we need to include this first. Go to the top of the file. Underneath the include for the iostream, add another include statement to include the string library. Now back in the code block for the main function, we can use a standard string data type to instantiate a variable that will store strings. Cool. Up to this point, we have now covered enough C++ functionality to store the values of different data types and display them to console. We can use this to complete the first of our work challenges. I will go through the first brief and show how I would break it down, then I will leave the other three down to you. As a point of reference, I will complete these myself and upload them to GitHub. A link is in the description. look for the Part 3 folder, where you'll find the project files for all the projects covered in this video, and the documents folder that includes the project briefs. So the first project brief is a project from a company called Too Cool Systems, and they want a program that they can schedule to run on startup of their desktop machines and display a memo to the logged in users. They have provided a template message which runs over multiple lines, and highlighted a number of sections they want as parameters that can be stored as variables to allow changes to be made later. So, breaking this down, I will start by creating a project and naming it something meaningful like startup memo. Then I'm going to instantiate all the variables I need: company name, TNC version, position or title, and the name of the sender. Then I will construct each line of text and store these lines as individual string variables and name them line 1, line 2, etc. Once all lines of text have been constructed, I will display each one to the console. And as part of a pro dev approach, then once I have a working program, I will review and identify any issues or errors in any areas that can be improved or refactored. So I'm going to start a new console project. Name the project Startup Memo. Remove unnecessary comments. Include the string library. Instantiate my variables. Start constructing my lines of text into string variables. Now lastly, I'm going to output these lines to the console. Let's build and run it. Okay, it's doing what's requested in the brief. It's a bit ugly, having the message split over a number of variables, but it will do for now. Later, once we have gone over control logic and algorithms, we will come back and see if we can make this a little more pretty. This is called refactoring, which we will be doing a lot more in future videos. For now though, this will suffice and is definitely usable. Although not as pretty as it could be, it does fulfill its purpose. Moving on to the other three tasks, here they are on screen. For one of the tasks, there is some indentation. For this you can use multiple spaces in the text, or you can use a tab escape character. Programming and developing software is an exercise in problem solving and research. To be effective, you have to be able to find your own answers, so I would recommend you take some time and look into escape characters for yourself and see what you can do. Experiment and try things out. This is the best way to learn. In the next video, we're going to start looking at capturing user input, control structures and logic flow. See you there.